Okay, we're on the On.NET show, and today we've got Emo Landworth, who's a program manager on the .NET team. We actually work together, I think.
Yes.
Yeah. And today we're going to do a deep dive on .NET Standard 2.0 and .NET Standard in general.
Right.
And I think we've heard quite a few questions about that.
Yep.
I think people are excited. They think it's a good thing, but don't necessarily completely understand it in all cases.
Right.
So let's do a deep dive. I think you are definitely one of the experts on this topic.
I better be.
Yeah.
Because I've spent 2 years working on this. So.
Yeah. I mean, how can it take so long?
I know, right? It seems such an easy concept.
So let's start.
Yeah, so I have a few slides, and then also I have tons of demos, and then feel free to interrupt me and ask questions.
Well, like I said, I'm going to provide the laugh track.
Nice. It may just me, but I don't know the answer, but hey. All right, so the big question really is, like, why do we care about .NET Standard? I mean, that's usually what is the first thing that people wonder, because they know .NET, and usually when they think of .NET, they think of the .NET framework. They may not call it the .NET framework, but that's effectively what we shipped 15 years ago. And the world was really simple back then, because we only had one framework to worry about, and you could build basically both types of apps that we advertised back then, right? Like, it was basically desktop apps with WinForms, and it was web apps with ASP.NET. And of course, you could build console apps too, and Windows services and what have you. But you were always on this one framework. So when you wrote your business logic, you would just use the .NET framework, base class library, right. PCL.
I remember that.
Good old days, right? And then over the years, we added more stuff. So there's Xamarin, for example, which does the same thing in terms of giving you a .NET platform that is really productive, but they focus more on the mobile devices, specifically the non-Windows ones, iOS, OS X, and then Android. Obviously, OS X is not a mobile, but like same thing there. It's basically, the idea is you build different types of apps, essentially, with their version of .NET. And they're built off of Mono. So Mono is very similar to .NET Framework, but it's not 100% identical. So when you talk about business logic, now you have two things to worry about, right? And then with .NET Core, there's one more. And so we have another mobile angle here with UWP, but then there's also the new ASP.NET Core stuff. And there's yet another BCL for .NET Core. And they're different because they're different code bases, right? So when we accept PRs, we usually accept the PRs on the .NET Core side of the house, because that's where the party is. And then from there, we port it to .NET Framework or Mono or whatever other implementations we might have in the future. And so, like, reusing code becomes now this multidimensional problem, right? And so, like, we talk about these things at the top as application models. That's the thing you build your app with. And the thing at the bottom, we just call them base class libraries. That is the general purpose stuff.
Right.
So we'd like to say it's 3 plus 1, because it's basically 3 different things, and the plus 1 is the, what's actually in common across all of them. So you have to keep in mind which APIs you can actually share. And so when you want to now write a library, you basically have to compile multiple times from multiple .NET platforms, and then it becomes really hard.
Right. I know when I was using the combination of .NET Framework and .NET Core 1.x,
right,
kind of before all of this completely landed, I was doing some file I/O. I think it was with FileStream. It actually wasn't with FileStream, with StreamReader. And there was one important method that I really wanted to use. And I was using it in .NET Framework, and then I copied the code over to .NET Core 1.x, and it didn't work.
Yes.
And I was left unhappy.
Yes.
Fortunately, some time passed, and then I tried to redo that same exercise with .NET Core 2.0, and that API was there, and I was happy, and I just went on with my work. Yes. So definitely had that experience.
Yeah. So like that's exactly the problem, right? And then if portable class libraries, it's the same thing, except it's even more complicated.
Yeah, I guess the other thing too is, like, with that code that I brought over, I was already using the best API. Like, it wasn't like I thought, oh, maybe there's some better way to do this that I didn't know about. I knew I was using the best pattern. So I was equally annoyed because I would have to do something that I fundamentally believed was worse.
Yes.
Fortunately, with this new model, that's no longer the case.
That's right. And so basically, when we think about .NET Standard, what it actually does, it basically tries to unify essentially that base layer. So you don't have that experience anymore where platform A decides to do something a little bit outdated, and then you don't have a way to do it the right way. And so you can think of the .NET Standard essentially as the one BCL to rule them all. I think we have said this many times, but logically, it's basically the set of APIs that really every .NET platform should have, because they're really foundational pieces like I/O, collections, and access to the console, like stuff you do basically in lower level libraries. And by low level really mean like non-app model specific stuff, right? Business logic comes to mind, data access layers come to mind.
Well, there's also a user promise, developer promise aspect to it.
Right. Which is basically the idea is that everything you put in .NET Standard will go everywhere moving forward, right? And we'll talk a little bit more how versioning .NET Standard works in general, but the idea being that the standard itself has version numbers because we don't have a time machine where we can retroactively add an API 5 years ago that doesn't work. So when we add new APIs, there's a new version of the standard, but the expectation is that all platforms will eventually move to the later version. They never get stuck on a version.
Right.
So you can't bifurcate essentially. It's always, you always move forward and consistency catches up over time.
Well, I do know someone who has a time machine.
You do?
Yeah.
Oh,
yeah,
yes.
yeah. So it's a great.
We should hire that guy.
Yeah, yeah. Actually, it's a woman now.
Oh, I guess that's true.
Yeah.
What's his name again? Or her name?
Well, it's still the same name, I think. She comes in December.
Oh, nice.
Yeah.
Cool. So then, what's the difference with .NET Standard to the previous picture? Is like there's only one BCL. I like to say it's not a Venn diagram because there's only really one thing with version numbers, right? And so that's easier than an overlapping diagram with multiple circles.
Definitely.
And then the other thing you pointed out is like with 2.0, we've added a ton more APIs, and I have a slide on that as well. But basically, we really tried to make the common denominator large. Like with Portable, we just modeled what we had, which was largely suboptimal. But now we actually went out of our way to make sure that we put a large common denominator that we think is sensible and is pretty large, and then we just fill in the gaps where platforms don't have those APIs rather than the other way around. And so the customer promise essentially is you can just target the standard, and we promise you can run anywhere where the standard is supported, or that version of the standard is supported.
Right. So you probably remember in grade school learning about lowest common denominator.
Yes.
I kind of think the PCL project that we did was a bit of a lowest common denominator project. This one, I think, in all honesty, is really like a largest common denominator project, particularly with .NET Standard 2.0. Do you think that's fair?
Yeah, I think to me the difference is more in intentionality. Like PCL modeled what we had, so it was an afterthought. Like every platform did whatever they want, and then we provided tooling that had to model what was there. With Standard, we said, this is what we want. Now let's make sure that all the things are there. And so we maxed out what we think was the right API set.
Yeah, one thing I sometimes tell people that I usually get blank stares on, so great topic to get into for this video.
That sounds great.
Yeah, is with PCL, all the profiles with the awesome names were all machine generated.
Yes.
So there was no human thought involved in creating those profiles.
That's right.
Which sounds super bizarre. And then so that's the difference with this, and that you used the word intentionality. So there was human thought involved in basically every single member that we pulled into .NET Standard. So yeah, it means now you have humans to blame. But I think that is a huge, huge difference.
I think so too. So then what is the standard? I mean, that's usually it all sounds great when you have like abstract diagrams, but really what it boils down to in Visual Studio is when you do file new project, you have this new category here called .NET Standard that has one template in it, class library .NET Standard. So it's a project type you can create. So that's the mechanical piece to it, and the actionable piece that you do day to day. The second part of it, it's a specification. So it's essentially a set of APIs that we say all platforms shall implement those APIs. So one way to think about this,
Can I just be a jerk for a moment? If you go
comes
back,
naturally.
Yeah, it comes naturally. Go back to the other slide.
Yes.
So this is just a tiny bit of a joke, but I think people will ask this. It's like, okay, I'm in the .NET Standard node. I see class library .NET Standard. Why do I see .NET Framework 4.5.2 there?
Oh, you mean the drop down at the top?
Yeah, I just feel like that's something to call attention to.
Yeah, so this is basically the end result of my very first slide when I said we used to have the .NET Framework and the world was good. And so we said, well, it would be nice if you could choose the version number before you create the template. And later on, when we added more .NET flavors, like, Silverlight at some point as well, like this drop down lost a lot of its value. It probably should be at the very bottom when you select the name, and it should be sensitive to the selection of the template, but the dialog is just not representing that. unfortunately, today.
Do you think so that future makes sense to me.
Yes.
Do you think that will ever happen?
I sure hope so.
Yeah.
I mean, I said it before on Twitter. I think this whole dialogue needs an overhaul. Like,
Yeah.
there's a little bit too many choices and names that are not necessarily reflective of how you think about the world today.
Yeah. Okay.
Yeah. So that's that. So then we think about the specification part. So if you think of the standard as a specification, a good analogy is HTML. So the HTML is a spec, and then there's the browsers who implement those spec. Right? I mean, there's Edge, Chrome, and each one of those browsers basically snap to a different version of this spec. But in the same way, it happens to .NET Standard. So the standard is essentially the HTML spec, and then the browser's equivalent is basically the concrete .NET platforms that implement it, like .NET Framework, .NET Core, Xamarin, Unity, and whatever we might create in the future. So that's a really good mental picture to have. So now 2.0, you already like said earlier, like with 2.0, we really try to add many more APIs back. In fact, we added about 20,000 APIs compared to .NET Standard 1.x or 1.6, which was the highest version in the 1x series. And the way we arrived at that number was basically said, well, what is the maximum we can envision? And the maximum that we can envision is take .NET Framework and take Xamarin and like build the intersection, because that's essentially a good proxy for APIs. They could be cross-platform, but they're still very similar to what the .NET Framework has. And then we also added a few APIs that were only in .NET Framework that Xamarin didn't have and asked them to implement them, so we don't have like a Franken set essentially.
So essentially, if we just go with the simple scenario that you mentioned, the intersection of .NET Framework, say 4.7, and Mono latest, that intersection that wasn't yet in .NET Core was around 20,000 APIs.
Correct. So most of the work was not revving the spec. Most of the work was then implementing the spec on Core.
Mm-hmm.
Framework was, by construction already supported. Xamarin had to add, very few APIs. I think it's probably less than 100 APIs we asked Xamarin to implement. And so we had like 20,000 APIs we had to add to Core. So that was the bulk of our work.
And we're adding them to UWP as well.
Correct. UWP is, on the first slide, it's like kind of lumped up with .NET Core because they kind of built from the same code base.
Mm-hmm.
So they don't get it for free, unfortunately, because UWP has a different runtime environment than normal Windows does. So there's work that happens at the OS to support App Container and all of that. But they will also get the same API surface. We'll ship later this year. I don't think we announced the date yet, but it will come. Then the second thing is, another interesting tidbit. When you try to create .NET Standard libraries with 1x, the problem you usually run into is, first of all, when you copy your own code, there's tons of APIs that you miss out. But that's in your control. You can refactor your code. It may be a ton of work, but you can do it. Usually where the story ends, though, is that you have dependencies on third-party libraries that somebody else gave to you, like think XUnit, for example, or JSON.NET, or whatever you actually use. And the majority of the libraries on NuGet today are not targeting the standard. They're still targeting .NET Framework because that's the thing that's around for so long. And so the question we had is, okay, how do we make this smoother? How do we make it easier for people to port to Core? So we added what we call the compatibility shim, or compat mode, which basically allows you to reference NuGet packages that really only work on .NET Framework today. And we try to go out of our way to make that work on .NET Standard, and by extension, any platform that implements .NET Standard 2.0. And there's a demo I have which probably explains this a bit better. But the idea here is it's a best effort thing. So we don't know what the library does. And if it uses WinForms, for example, it will not work on a command line app on Linux, obviously. But the majority of libraries we found in NuGet, about 70%, are API compatible with what we have in Standard 2.0. So in practice, most of the time when you upgrade and you just reference an existing framework package, it will probably just work fine.
Right, so I get the caveat emptor nature of this.
Yep.
As a user, it would be awesome if I could say, I'm currently using blah NuGet package. It shouldn't really be the case that I have to go explore that completely by myself if it's in this 70% bucket. Mm-hmm. Are there any lists anywhere that I can go look at?
You mean like lists of NuGet packages that we know will work?
Yeah.
No, I don't think we have a list today. That's actually a good suggestion. We should probably have a list.
Yeah.
The other thing we want to do is we want to reach out to the NuGet authors and actively encourage them to support .NET Standard natively, especially when they're already de facto compatible with it anyway. It just takes an explicit step on the package to say, yes, I support .NET Standard 2.0, so that it's also more intentional on the package author side.
Well, if we were super strategic it seems like we would maybe like we'd say, oh, these are the 100 most popular libraries that only have .NET Framework dependencies, and reach out to them.
Yes.
Has your team thought about that?
Yes, I mean, you should know he's my boss, so but he's basically telling me right now is I should go do this.
Get it on tape.
Get it on tape, it's public now. We actually did this, like this number basically, we came to that number by basically doing what you just said, that we did a whole analysis on NuGet packages. There's actually a video where I walk you through the deck of like all the findings we have. What we haven't done is, because it's more like a quantitative effort, we haven't really drilled into this and like actually reached out to them. But there are a few like high-profile packages where we actually ended up submitting PRs directly to the GitHub repos.
That's even better, actually.
To actually fix it and add .NET Standard natively.
And were those PRs accepted?
Yeah, most of the time, yes. I mean, some of the time it was, especially when we did it at the 1X, like the delta in the code was pretty large, and people didn't feel like, well, that seems a lot of like disruption in my code base. With 2.0, it's mostly you add another folder to your NuGet package, and that's pretty much it. Like, depending on how you build the project, you may actually end up adding a TFM to the project too, so you get the compile time checks as well. But it's a very minimal delta on 2.0 for the most part. So 2.0 changes are mostly accepted, I think. I'm not aware of anybody pushed back on that.
Right, so that's an easier conversation with the maintainer.
Much easier, yes. All right, enough of the slides. Let's actually look at a demo. So what I have here is, fortunately the font is not amazing, but you can probably see it on the video screen quite well. So basically what we have here is Northwind, and anybody who does .NET development for a long time is aware of Northwind. And so I have a very simple app here. It's a WinForms app. And you can clearly tell I'm a designer because when I change the size here, the button sticks to the bottom right corner. So I did a really good job there. But basically all I did here is I load some of the data from Northwind and look for people that are retired by now, so you can tell like how old this data is. The key thing here is that my actual database right now is not SQL. It's actually using dataset, which was our in-memory representation of databases in the 1X days.
Can you maybe zoom that in just a tad?
I can, I think. Maybe do this. Maybe 150 is probably even better. Here we go. And so what you can see here is basically all I do is I just create a data set, loaded hardcore from file, with like a hard-coded path, like a really great development story on my side. And I just look for people that are retired, right? It's such, birthday plus 65 years, which is the German retirement age. I think Canadian is probably more like 40. I've heard
yeah.
The US is more like 120, so
yeah.
Should parameterize that. But basically here is I just search for that and just display that. So what does it do with .NET Standard? So dataset is one of those APIs that we considered legacy and basically removed from the 1X. But turns out people may not be in love with dataset, but the reality is you're even less in love with having to refactor a code base to get rid of it.
Definitely. And we did hear quite a lot of feedback on that topic.
And there is a bunch of stuff that actually is useful. So what I will do now is I will create a new project. I will go to the .NET Standard category as we talked about, select .NET Standard, and we'll call this, let's say, Northwind Data. Data 2, I already created the project apparently before.
Been there, done that.
Exactly. So, and then I just delete the class 1. And then I just take my data access logic now and just move it over to my new project.
Nice.
So now I have it in here, and you can tell there's no squiggles. Everything just works fine. If you actually go to the project properties, you'll find out that we target .NET Standard 2.0, because that's what we default to now. Yeah. If I switch it to 1X, you will get tons of squiggles. So now we have a modern code base, right? Not quite. Let me modernize it a bit more. There's all these explicit types. So let me just do this. Now I see var everywhere. Now it's awesome. Right now it's a modern code base, clearly.
Definitely. That's the one that Casey doesn't like, right?
Exactly.
Yeah.
The nevar people.
Yeah.
So now we have this, but now let's actually extend this and say, I'm not keen on this, hard-coded lookup here. So what I've done, about 10 years ago, I think I wrote a SQL engine that can actually allow you to do this, the same thing I do here right now with C# with SQL. So let's actually add my library here. So I just go to my NuGet packages, I search for my library on NuGet, find my library. You can tell here uploaded 2012.
Is that still when you had spare time?
That's when I still had spare time because before I worked for you, now I no longer have spare time.
Well, you also had a child at some point.
That's true too. So I install this thing. It succeeded. However, when we now build, when we look at the error list, we see a warning here. And the warning says, nQuery was restored using .NET Framework 4.6.1 instead of the target framework of .NET Standard version 2.0. So why is that? Well, if we just go to NuGet.org and we just search for my package here, and we just download the package, and we open this in Package Explorer, it's very obvious what the problem is. If I look in the lib folder, so in 2012, I think I originally wrote it, I think, in 2005, 2006 timeframe. So that was when .NET Standard 2.0 was all the hype. So that's what I'm targeting. So there's nothing, nothing PCL, nothing .NET Standard. It's just a good old .NET Framework binary.
You might give a quick shout out about what this app is for.
Oh yeah, this is it's called NuGet Package Explorer. It's actually in the Windows Store. If you just go to the store, you can search it there. And it allows you to open NuGet packages and browse them visually. I mean, they're just zip files, but that's a bit nicer too, because you see the metadata here nicely rendered.
I definitely use this app multiple times a week. You probably use it every day.
Oh yeah, every time I do demos at least. So we have that, and now what we can do is I can now reuse my library. So let me get rid of all my hardware logic here. If I could find a way to use the mouse. Maybe not. Maybe to do this. And then we just delete all of this stuff here. And then instead drop in some code that I've written earlier. So that's using my nQuery library. I have to add using at this point. But basically all it does, it just creates a data context that holds onto the data set. So it's effectively a connection, does a SQL query, uses some link magic to render the result. And if I run the app again, it doesn't build anymore. Oh, because I have to add a reference to the library, of course, as well. Just creating the new library doesn't quite help. I also have to reference it, I've been told. Now we run this again. It does the same thing as before. So now you have basically moved your stuff to .NET Standard 2.0. So this could be no reference from any library. We could reference it from ASP.NET Core. We could reference it from a Xamarin app. But what you see here is there's this warning. You can also drill into this warning in Solution Explorer that shows you the same thing. So the intent here is we let you know this is going through the compat shim. We don't know what this library does, right? It may use WinForms. It may use APIs we don't have. So the intention here is you test your app. You convince yourself that it's working fine. And then you effectively just suppress the warning. As you see here, like there's this warning number here, which is NU1701. That's the warning number for the compat shim. So all you have to do is you select nQuery here, and then you just put the warning number here, hit enter, save, and now you can see the warning disappears from Solution Explorer, and it also disappears from here if I rebuild.
So one thing I was playing with recently, it was either this weekend or last week. I was playing with the warnings as errors dialog. Can you talk a little bit about what builds? So we know that a number of folks operate with warnings as errors.
Right.
So in this kind of model, is that incompatible with that kind of system, or can you speak to that?
Yeah, so the idea here is, I think, so what they've done now with the latest version of NuGet, the latest version of VS, is that they have kind of bridged the gap between warnings from the compiler and warnings from NuGet. So they are all in the same UI and the same experience. So for example, here, you see specific warnings already suppressed, specific warnings already treated as errors, for example. And so you can change those settings, and you can, for example, say, I want the NU1701 to be an error, so I don't want to ever go through the compat shim. The other thing is you want to suppress the warnings.
And where would you specify that if you wanted to have a...
You would specify it right here in the UI. So
okay.
I would basically say treat warnings as errors. I would say NU.
Okay.
Now it becomes an error, right?
Okay, I see.
The other thing is, if you look at the project file itself, it just persisted with the same no warn MSV property that compiler warnings are suppressed for. So it's a very simple workflow now. You can just add it there, and then it will just treble.
Right. So for people that have those kind of build systems, this should play just like everything else.
Yes. And the idea generally is, like, if you suppress a warning, it's addressed. So even if you have warnings as errors on, like a suppressed warning is no longer causing the build to fail, essentially, right?
Got it.
Alrighty, that was that demo. Let's go back to the deck. So the other question usually is version numbers.
Right.
There's multiple versions of the standard, and then the question is, how should you think about the version numbers and how you would make a decision what you want to target. So I have written some HTML, which I probably should public. It's actually on GitHub. You can actually get it from there, but I don't have a link for that yet. But basically what you see here is this table that seems to confuse everybody all the time. The table is actually not that hard once you know how to read it, but it's not obvious. So what you see here is at the very top, you see the version numbers of the standard. So you can see like from 1.0 to 2.0, what kind of version numbers do we have? And then what you see at the vertical axis is essentially all the .NET implementations we have. So for instance, here you can see right now we have selected .NET Standard 1.0. And what you see here in green is essentially all the .NET implementations you can run on and what the minimum version number is you need to have. So for example, if I want to run a .NET Standard 1.0, or if I want to target .NET Standard 1.0, that means I can run a .NET Core since version 1.0. I can run .NET Framework since version number 4.5.
Which means you just can't support something before that.
Correct.
Like 4.0.
Yes, so 4.0 we don't run on, for instance. The other thing you see here is you see also by the shape here that the .NET Core doesn't actually directly implement 1.0. It actually implements 1.6, which means I could now target a higher version number and still run on .NET Core 1.0. Mm-hmm. So for example, now when we target 1.1, what you see now is that all of this stuff becomes unavailable. So for example, I no longer run on Windows Phone Silverlight, which hopefully nobody cares about anymore with UWP, but that's how this table basically works. And then when I go up even further, if you just toggle through this, you see essentially this red trail of stuff you no longer run on. And now you can see, for example, I now need to .NET Framework 4.6 if I need to run on .NET Standard 1.3. That's basically how to read the table. Then at the very top, you have this blue bar here, which is kind of like a proxy for the number of APIs we have. So as I'm going back, you see there's some jump between 1.0 and 1.1. And then between 1.1 and 1.2, there's only a minor jump. And then once we reach 2.0, you see this massive spike where we added all the 20,000 APIs to this whole thing. The version numbers here are not all up to date, but the .NET Framework one is. So when you want to target .NET Standard 2.0, you basically have to run .NET Framework 4.6.1 and up. You don't run on 4.5 or 4.6, for example. That's essentially how to read this table. Does that make sense to you?
Mm-hmm. Oh, I see. So shouldn't this column, this cell, just say 2.0? .NET Core 2.0?
Yeah, it should say 2.0 here. I forgot what the version numbers here are.
Yeah, but we could fill that out, right?
Yeah, we can fill this out. Like there's an up-to-date version. If you go to our FAQ, there's an actual versions table that we have here. That's the same that we have in the docs.
Okay, so that's up to date.
And so you see the actual version numbers here. I just haven't done it in the HTML-ified version of that.
Okay.
But yeah, that's the same thing. So then the next question often is, okay, how do you decide, right? And basically it's a trade-off. You have to decide between, the higher the version number of the standard is, the more APIs you have. The lower the version of the standard is, the more reach you have, because the more platforms support that particular version, right? Which is kind of intuitive, but it's still worth pointing out because people get confused about that. A corollary of this is because this is a spec, like a version number doesn't go out of support.
Right.
So because it's basically just the number of APIs you can access, essentially. And so generally speaking, even though that we have shipped 2.0, you should not feel guilty for targeting 1.6, 1.4, or 1.0 even. Because if you can target 1.0, by all means, you should target 1.0. You should only bump the version number when you need more APIs. Implementations on the other side, they have a support policy, right? And so, for example, we may decide that, let's say .NET Core 1.0 is out of support eventually, and then you have to be on 1.1 or 2.0. And that just means you can now target a higher version of the standard as well, but you can always target a lower version number to get more reach.
Yeah, you're basically saying the .NET implementation versions and their support policies have no relationship to the .NET standard versions.
Correct.
We intend to support these .NET standard versions forever.
Yes.
There's no reason for us to deprecate them. Yeah, we have no plans of ever doing that.
And there's also no breaking changes, right? Like the version numbers are all monolithically increasing, and you just get more APIs. You never remove APIs from it.
Right.
So that makes that possible.
Well, not only do we not remove APIs, right, I guess that's what you said. Yeah, and we never go back and either add or remove APIs from a given version that we've already shipped. Then it's immutable.
Yes.
Which
So it's a very simple model. So target the lowest version you can get away with. Then the other thing we should point out is for people that are used to portable class libraries, if you go to if you go to Visual C#, there's this thing called class library portable. And if you read the text closely, you see it now says legacy portable. So we basically try to tell people, stop using portable class libraries. And then the text we also say this has been deprecated, you should use class library.NET Standard instead. So .NET Standard is the spiritual successor of portable class libraries, but it's a much better tooling story, partially because we have much more API surface, and secondly because you can still reference .NET Framework binaries, which is huge, because that was usually the biggest thing with portable, that you could only reference other portables, you could never reference anything else.
Right.
And so that really gets you unblocked.
Yeah, so I think there should be very few scenarios where PCL was better.
Right.
It's like a 95% better kind of thing.
Yeah, I like to think it's always better. It's just that some platforms are no longer supported, that are no longer supported by .NET Standard, also not supported by Visual Studio, so you're really not losing anything realistically. So you should just move to the standard, and it's generally an upgrade. Yeah, that's I think what we have to say about portable. The other thing that often comes up is multi-targeting. So usually what ends up happening is people at some point run into APIs that don't exist in the standard. So what I have here is I have a solution with 4 projects. So I can just run it really quickly. Yeah, probably get an error message from the UWP app. So let me just deploy this guy first.
Yes, another one of my favorite error messages.
And now when I run it, I have 2 apps. You can see I've had this open before in a larger screen resolution. And so they both do the same thing. So I have a WinForms app and I have a UWP app, and they both do the same thing. They just show you the longitude, latitude, where you're located on the Earth, right, using the geolocation APIs from the operating system.
So if we'd run that app yesterday, we could have said whether you're currently experiencing an eclipse.
Yes, we could have done that.
Why didn't you think about that?
I don't know. Didn't occur to me. So what I have now is I have 2 libraries, because I want to share the how I can access the GPS subsystem. So let's first look at the .NET Framework implementation of that. And effectively, what you have here is you basically use system device location, and it's you have to do this little dance, because the first time you call it, it may not be initialized. So you do this little thingy here, and because it takes a while, I have an async version of that, so I run it on a worker thread. But essentially what I return to you is just a tuple of longitude, latitude, right? Get coordinates. Reasonably simple.
Mm-hmm. A task of tuple.
Yes, because it's an async API. And then I do the same thing on the UWP side, except now I use different APIs. Now I use the WinRT API. So you see here I use Windows device.geolocation. And this API is already asynchronified, so I don't have to do like a worker thread or anything. I can just return this guy. I just await it, and then I just return this thing, and then I'm done with this. And the reason I put this in libraries so I can reuse this across all my WinForms app or across all my UWP apps, right? But the problem is I still have 2 libraries. I have one for .NET Framework and I have one for UWP. So now when you look at the references here, I have to know which one to reference. So the UWP one references the UWP version, and then the .NET Core version references the .NET Core version, sorry, the .NET Framework version.
Yeah, I guess one of the things you're doing here is, and maybe this is too deep dive, but
it's a deep dive. So.
In this particular case, if the type that you were using that you got from the operating system was a .NET type, you could have actually just returned that position and not pulled the lat long out of it.
Correct.
I think what you're doing is you're basically converting the WinRT representation and type into something more agnostic.
Correct.
And that's why you have to await it and convert it to just these 2 2 doubles.
That's right.
Yeah.
So
and so then that's what makes the 2 sides compatible.
Yes. Well, that's the goal, right? So if you look at this part up here, GPS namespace, GPS location, static method get coordinates tuple, that actually looks exactly the same between the WinRT version and the .NET Framework version. And that's not, as you said, it's not an accident. I did this deliberately.
Right.
So because now I can use my magic wand and just switch to another branch where I did this work, because you don't want to see me fighting with my non-existing mouse, I should say. Now I have a single project called GPS. I have a single file called now GPS location. And now you see, instead of having two libraries, you just have one library, and you just have some if-defs in the code base. And so what you see now here is in this little drop-down here, you see there's 3 entries. There's .NET Framework, .NET Standard, and UWP. And if I added the project here, normally it says target framework, a singular, and then it says whatever you're targeting, .NET Core, .NET Standard. And I just made this a plural, and I just now target the standard for framework and UWP.
Can you do that with all MS Build properties?
No, unfortunately not.
Okay, just checking.
But what you can do now is, because the project is now effectively compiled 3 times. And so what I can do now is I can say I want to have this reference to this NuGet package for all my 3 compilations.
Right.
And I can say, when you're targeting framework, I want to do this extra reference where add the reference to system.device. So you can do whatever you want in MS Build using these expressions here. You can basically now say, oh, if the target framework is 461, then I do this, otherwise I do that.
Where's the closing project tag?
It's very much at the end, because there's still some ugly stuff I have to do.
Oops.
But
I asked a bad question.
No, you asked the right question. But logically, that's what you have to do.
I see.
And so now what I have here now is I have basically one method, and I can just if-def this thing. What's interesting now is I also target .NET Standard, which I haven't done before. So what ends up happening now is I have an implementation for this standard, and that is not very useful. It's those platforms not supported. But what I can do now is I can...
So is this a little bit like, this is basically like the bait and switch pattern?
Yes, that's exactly what it is. So let's first start by saying, let's produce a NuGet package out of this. So you just go here, say package, generate NuGet package on build. That's also a new feature we have.
Is that that's new in 2017?
Yes, I believe that's already in 15.1 even.
Yeah.
So now when I build this guy, I just go to the output folder. First of all, you see there's 3 folders for the 3 different TFMs we target.
I feel like we're going to use NuGet Package Explorer again.
Exactly, but there's also one package, and only one package, not 3. And this one package...
So 3 folders.
There's 3 folders, and then within the NuGet package, there's also 3 folders with the 3 binaries that we just produced. So we basically did one pass, so we created the .NET Framework version, one for the UWP version, and one for the .NET Standard version. So you have 3 different binaries. They're all packaged up. The consumer of this package now doesn't have to know that I have to do something different for platform A and platform B. I basically abstract this away.
Nice.
Now you might say, well, but hold on. If I reference this from anything else, I just explode at runtime. That doesn't seem very useful. But it still is, because because I can still do this, right? I can do public bool is supported, right? And now I can do the same thing I do here. I just instead of exploding, I basically do this, where I just say, if .NET Framework or UWP, I can just say return true. Else, I can say return false.
Nice.
So now my caller doesn't have to know which platforms are supported. My caller can just say, can I access the, and it probably should be static, because that's where the squiggle is coming from. It's a static class. But now the caller can check up front. So now imagine you do a Twitter client, right? And the Twitter client wants to tag your tweets with the geolocation.
Right, of course.
And clearly, if you can't access the device, nothing bad happens. You just lose, a minor feature on your stuff, but your app could continue to work. So the intention is that callers will now say GPS location is supported. If so, call get coordinates, and then the caller is responsible for guarding the calls correctly. But the nice thing is the caller doesn't have to know which platforms.
Right.
So you can abstract it basically for everybody.
Right. So I've used shared projects before.
Yes.
This seems like exactly the same thing. So what's different with your .NET Standard approach versus the shared projects one that I use?
Yeah, so the shared project one's approach is logically the same. You basically have one project that holds all the source files you want to share. And
looks very similar. The code looks the same, right?
Exactly. And then you have, basically for every single TV you want to target, yet another project. So in our case, you would have 4 projects. You would have one for the standard, one for UWP, one for .NET Framework, one shared project.
I see, because a shared project is almost like a virtual project. It actually doesn't build any assets. That's really the difference.
It's just linked into the other projects, right?
Right. So it's this convenience layer, if you will. Okay.
So instead of having to maintain like menu links to 100 different source files, You put them all in one project, and they're all implicitly linked from there. But OK, now you have 4 projects, but you also don't have a NuGet package out of it yet. So you also have to provide a NuGet package, a new spec file that you write by hand, and build the package.
And then you couldn't build a single NuGet package. Well, yeah, I guess that's the by hand piece.
You would basically have a post-build step that, once all projects are built, you just copy the binaries in the right.
Yeah, so you wouldn't get this nice built-in MS Build feature.
That's right.
Right, so this is a big step forward for that scenario.
So the nice thing here is, our advice generally is if you need to multi-target, you should always have it also a net standard target. And then the version number you choose there is a function of essentially what API service do you need to expose. Right? It's no longer a function of the implementation. It's about which types can you use in your public surface area to bridge the platform differences.
Right, and that's analogous to .NET Standard versioning.
Correct.
Yeah.
Yes, very much so. And so you just pick the lowest one you get away with. Easiest way to tell is just lower the version number until it stops compiling, and then use the previous one that used to compile, and that's the minimum you can.
Right. Now, if you did this, though, you might be able to have slow increase of the .NET Standard asset, but the NuGet package version would basically increment every time you had to make a bug fix in any one of the platform-specific implementations.
That's right.
Yeah.
And so this is basically a mechanism for you to bridge platform differences and not feeling confined to the API service of .NET Standard itself, and still shield your consumers from having to think about multiple platforms. So that's basically the open-endedness of the .NET Standard promise.
So I feel like we should just, I know this is somewhat obvious to you, but I think we should just talk for like 60 seconds on these preprocessor directives so that people grasp what they do and when they run.
Yes. So what ends up happening here is, as I said before, this project compiles multiple times. And then the compiler is basically invoked for the same code base 3 times, right? But it's also passed different preprocessor symbols. And they are basically implied from the name of the TFM. So just think of the TFM you see here. If you just go.
So it's kind of a convention.
Yeah, it's basically it actually is exactly a convention. The only thing is a bit odd is UWP, but like all the other ones are following the same thing, where they're just too upward, and then essentially we replace the dot with an underscore, so we make it a legal identifier.
Makes sense.
So you know exactly what they are here now. The nice thing here is in the editor, it basically shows me all the context. So what I see now is when I'm compiling for UWP, that this code path is active, and that this code path is active, and that these other ones are grayed out. So the other ones are essentially not considered part of your source code. If I now switch to, let's say, 461, this is still active because you said OR, but now this code is being compiled and not that code. Right?
So you get good visual cues.
You get very much like a visual representation of what's going on. That's right.
Right, but just to really drive the point home, can you explain the difference between the pound if and the regular if?
Yeah. So the difference here is that this if statement here is evaluated at compile time, right? So when the compiler runs, it evaluates this thing and says, great, I need to consider this code. And so it's basically the end result is as if you would have only written this piece.
Right. So
the compiler sees it.
The other part that's in else, it is discarded. Like the compiler never even basically reads the line 15.
You can have even syntax errors here. It doesn't even matter.
Oh, okay. I didn't actually know that.
Because it's just text that's skipped, right?
Party on. Yeah, so the compiler literally doesn't see those lines.
Yes. And then the other nice thing is because of the way it's set up here, because it's a single project references are also doing the right thing. So you see that all these project references just reference this GPS project, and they will generally get the correct implementation depending on who they are. So this project will get the UWP side, and this project gets the .NET Framework side. So even if you don't build a NuGet package, using multi-targeting within your solution can just drastically reduce the number of projects you have to think about and having to maintain. So it's a really powerful feature.
Cool, I like it.
Yeah, it's pretty nice.
Actually, a good question. One of the things we didn't talk about is, I guess it doesn't matter now since we shipped Visual Studio 2017 15.3.
Right.
But just to drive home the point that if you want to use this stuff, you need Visual Studio 2017 15.3.
Yes. So
Which
most of the
like a
stuff I
week
just
ago.
showed you, like multi-targeting, I think is something that shipped earlier.
Yes.
But as soon as you talk about .NET Core 2.0 and .NET Standard 2.0, you
Yeah.
have to be on 15.3.
Right.
Like you can't be on 15.2 or 15.1.
It basically doesn't work.
Yes. There will be, I don't even know what the errors are you're getting, but there probably is some unhappiness involved when you go down that path. All right, so like the one URL you should remember is this one here. It's net standard FAQ. It points to our document I showed earlier, which is actively maintained. So if you have questions that we haven't answered yet, I would generally just add a new section to this thing here. And so I have a whole bunch of questions being answered here. Like, for example, why is James Newton King's JSON not part of .NET Standard, for example? And how does versioning work? Almost everything we just talked about is listed here. And from here at the very top, we also have links to other resources. So that's why it's basically your one stop shop, I guess, for everything .NET Standard. We link to our docs. We have a video series that I created on YouTube. Our conceptual docs, our API docs are being linked here. So for example, if you want to find out what's actually in .NET Standard 2.0, you can actually browse it as well. You don't have to just use IntelliSense in Visual Studio.
I know, that experience is really nice.
It's super nice, like especially when you search for types. It's super, responsive, right? Something we never had before in MSDN.
No, definitely.
And we actually use the
whole width.
Screen. Like
yeah,
it's amazing.
Turns out you can.
It's almost better than GitHub because GitHub only uses like that part.
Yes.
Anyway, so that's the URL you want to remember. And then, of course, if you have questions, you can reach me on Twitter. You can shoot me an email. I get a ton of emails. I may not be super responsive on email. You have a higher chance actually hitting me on Twitter than on email.
Yeah, because that's what you do. You get home, and then it's just Twitter for the rest of the evening.
That's totally true.
Yeah.
And then my wife gets 5% of the time.
Okay, great. Okay, I think we're kind of coming to a close here. I think I've basically asked all my questions.
Sweet.
Actually, I have a good one that a lot of people ask. So, the .NET Core team is starting to think about .NET Core 2.1.
Right.
Big surprise.
Yes.
Haven't really finished the planning there yet, but there will be such a release. So does that mean there will be a .NET Standard 2.1 at the same time?
So not at the same time. So I mean, today it's somewhat coincidental that .NET Standard 2 and .NET Core 2.0 have the same version number.
Okay.
Like it could have been .NET Standard 3.0 and .NET Core 2.0. Like they're not meant to be in lockstep.
Okay.
Right? So we will ref the standard like over time as well.
Right. So 2.0 isn't the last version.
It's not the last one, and the next one is probably going to be called 2.1, 2.2, 2.3. But you could imagine a world, for example, where let's say we add .NET Standard 2.1. But then the corresponding .NET Core version it implements happens to be 2.2, right? That's entirely possible depending on how fast we ref core with respect to the standard, right? So core may ref faster than the standard does because the standard would generally ref at the cadence where we can agree on, oh, here's a new set of APIs you want to have everywhere. Let's add them to the standard. They form a nice set. Okay, let's call it 2.1. And then we work with all the implementers of the standard to bump the implementation to implement 2.1.
Right, so is that basically the plan, which is new concepts that show up in .NET Core first, they get proven, and then some combination of being added to other implementations like Xamarin and .NET Framework, and added to .NET Standard happen next. Is that?
That's right.
Yeah.
And some of the APIs may be existing APIs that we haven't standardized yet. Some of the APIs may be net new APIs. And so net new APIs generally go on core first, I guess, at least when you're from a BCL standpoint, because that's the part that's open source. That's the part that we can make changes relatively fast. And yeah, the general idea is we vet APIs first in a concrete implementation, and then from there we put it everywhere else.
Yeah, I guess we actually never talked about this even in our planning, but we ended up here because it's obvious.
Yes.
But I guess we actually do have this rule that. We only put things in .NET Standard that can be open source.
Yes, I mean that's a logical side effect of the core stack being open source.
Yeah. Okay.
All right, then that's pretty much it.
Yeah. Okay. Well, people have places to contact you.
That's right.
Read our blog, and this was awesome. I learned a lot.
Yeah, I enjoyed it pretty much.
Okay. Thanks everyone for watching another episode of On.NET. Appreciate it.
Bye.